Okay, when you think of momentum, what do you think of? You probably think of maybe a car, or maybe you think of a football game. If a car were to run into something, it has momentum. It could do damage to it. Maybe you're thinking along that line, or maybe you're thinking like it's a tie football game, and then your team gets a score, so you move ahead, and you've got things are going your way. So that's kind of like I don't know what would I call that. That would be like social studies momentum, I guess. But in science class, when we study momentum, momentum is math, okay? And it's actually not too difficult. The math of momentum is so momentum gets the letter P. Why don't we just call it M? Well, maybe you'll see why in a second. Because momentum equals mass, whoops, times velocity. And we can't have m meaning two things in the same equation. Mass and momentum both start with m. So there's an old Latin word, I don't remember what it is, but there's an old Latin word that it means something quite similar. So we just went with that one, and that started with P. So anyway, momentum, the equation is P equals m times v. It's pretty simple. Kind of like, distance is speed times time. It's that easy. So what do we measure these things in? Mass, we measure in kilograms, and velocity, we measure in meters per second. So that means the momentum unit is a combination of these two things. It's actually kilogram meter per second. Okay. Oftentimes you'll see a little dot written right here. Quite often I'll ignore that. So it's kilogram meter per second. That's the unit of momentum. It kind of does surprise me a little bit, because usually if we have, I don't know if this is a complex unit, but if we have weird units in science, quite often they'll get named after famous dead guys. We'll talk about a couple of those later. Anyway, let's just do a problem so you can see how easy this is. So let's say that we've got someone like me, and my mass is, depending on what season it is somewhere around 90 kilograms. And let's say that I'm moving with a velocity, and I'll cover this in a second. I'm going to kind of ignore it for now, but we're going to say that my velocity is 2 meters per second. So what is my momentum? Well, my momentum is my mass times my velocity, and that turns out to be 180 kilogram meters per second. Now, momentum is what we call a vector. And what does that mean? That means that it always has a direction. So quite often you'll see it momentum written as like with a little arrow over it, or an arrow over the velocity. But in this class, it would be good enough for us to just say, which way is my velocity? We could say that I'm going east. So that would mean my momentum, excuse me, my momentum is 18 kilogram meters per second to the east. So maybe I should redraw that box. So the direction of an object matters, of an object's momentum matters, because it is a vector. Think about this. Think about maybe you've got a train car going this way. We'll call that positive. And you've got another train car going this way. We'll call that negative. Let's say these two train cars are going to hit, and they're going to stick together. They're going to lock together with their little locky dealies they've got on them. But anyway, let's say that this one right here on the right has, a very huge momentum. Like let's say 20,000 kilogram meters per second. And actually, that's probably small for a real train car. But anyway, and let's say the momentum of this one is only 10,000 kilogram meters per second. When they collide and stick together, which way are they going to move? Well, that's where we use momentum, because when objects collide, what happens depends on their momentum. And common sense will tell you guys that since this one has so much more momentum than this one, that the final combination of the two is probably going to be moving to the left. But solving problems like that, we might do something simple like that. I don't think I'm going to throw it on the mastery quiz for just the basic momentum, but maybe I'll have an advanced momentum quiz with more collision stuff on it. So before I finish, I should probably do a couple more problems because, let's see here, because I haven't talked to you about what if I give you the momentum. Let's say we've got a momentum of 40 kilogram meters per second in a certain direction. Let's leave that off for now. And let's say that its mass is, 5 kilograms. Can we figure out its velocity? Well, if P equals m times v, how do I get the v by itself? I divide by m. So what we wind up with is v equals P over m. What will happen is our kilogram meters per second is over our kilograms, and our kilograms will cancel, and our unit will be in meters per second. And that's good because that's what velocity is measured in, right? Meters per second. So P divided by m, 40 divided by 5, that is going to be 8 meters per second in some direction. But I didn't tell you what the direction was up here, so I kind of couldn't tell you down here. And then the third and final flavor of problem that I could give you, I could say that something has a momentum of, let's say, 3 times 10 to the negative third kilogram meters per second. And let's say that its velocity is 700 meters per second. We could say up if we wanted to, or some other direction. It doesn't really matter. But how would we figure out the mass? Well, if we go back to our original equation here, if we want to get m by itself, how do we get rid of a multiplied v? Divide by v. They cancel out. You do it to both sides, so m equals P over V. So what's our unit going to be? Well, we've got 3 times 10 to the negative third kilogram meters per second divided by 700 meters per second. So you can see that what cancels out there is meters per second. That's gone. So our answer is going to be in kilograms, and that is good because that's what mass is measured in. So what math do I have to do? I have to go 3 times 10 to the negative third divided by 700. So on my calculator, I'm going to go 3 times 10 to the negative third divided by 700. And I get 4.29 times 10 to the negative 6. So 4.29 times 10 to the negative 6th kilograms. So whatever this thing is, it's not very massive. Negative 6, that's like, who knows, a speck of dust or something. So anyway, that is how you solve momentum problems. And momentum is a vector. It does have a direction. And that's it.